All right. Are you able to see the slides now?
Yes, the screen is visible, sir.
Okay. All right. I may have to switch to a browser later. So yeah, let me start. Thanks for the invitation and thanks for the kind introduction. Hello, everyone. Good morning. It's Friday around 10 p.m. in San Diego, California. So I'm happy to be here and share whatever I know about this. So yeah, before I go into the details, let me add a couple of things. First of all, there is some bad news. You all have homework to do, okay? And the good news is you don't have to submit the homework to me. If you do the homework, you will learn more. So that's a good news. So another thing I want to add is, all right, so yeah. All right, another thing I want to add is I have a lot of slides and the subject itself is very complex, but it's one of the hot areas that are coming up. So I have added quite a few website links to my slides. The reason is twofold, right? One is people have done an outstanding job of explaining some of the concepts. And I also want to give credit to them, as well as later on when you use the slides, you can click on these links and you will learn more and more. So that's the reason I have done that. So with that, let's start, right? So what is deep learning, right? So as you can see in the slide, right, it is a subdomain of artificial intelligence. What is artificial intelligence? I'm sure you all understand. Any technique that enable computers to mimic human intelligence. Would they ever reach that level of human intelligence? That is a question to be answered in the future. Now, artificial intelligence is a very big umbrella. There are multiple techniques that go within that umbrella. One big item under artificial intelligence is machine learning. Machine learning is basically a set of statistical techniques that enable machines to improve the task they are doing. So under machine learning, there are, again, various subdomains under machine learning. One such domain is deep learning. For the last 4 to 5 years, that's what I'm working on in Qualcomm AI research. So that's what I'm going to share with all of you. And as I mentioned, it's a highly complex topic, but I will try to make it as simple as possible. The reason I'm saying complex is it's impossible to talk about this within 30 minutes or 40 minutes, but that's why I have added enough pointers which you can all explore. So coming to deep learning, it's like a subset of machine learning algorithms that permit software to train itself. So the key words I have highlighted at the bottom here: software to train itself, and using neural networks and vast amount of data. So those are the key things. These topics I will cover as we go along. So before we just saw from a high level what is deep learning, right? And now why I think it's why it is getting importance now, and why pretty much all the countries, every company want to do something to want to utilize the power of machine learning. Okay, let me see how these links work now. Okay, all right, so that's good. So I'm just going to give few examples of the why. Okay, why I think these are some of the applications that really touched me. And those are just 2 examples. There are thousands of examples like this. This is an app in Android. And what
Excuse
it
me, sir.
does,
Sorry to interrupt you. Only the presentation slide is visible. Probably the
okay, all
browser
right.
is not.
So, yeah, okay. I think I had to switch back and forth. Okay, thanks for pointing out. Are you able to see it now?
Yes.
Okay, thank you. If it happens again, please remind me.
Sure.
Okay, so yeah, so I was talking about Air Cognizer is an app. It is developed by students like all of you. Okay, so you all know how bad the air pollution is in Delhi, right? It's well known, it's known worldwide. So these students tried to solve the problem by building an app using one of the TensorFlow is Google's machine learning framework. So they used it. I'm just going to keep it at a high level. You can play this video and you can learn more. That's why I added all these links, okay? So they will connect to your server. They will get the data from, the air quality measurements. And all someone has to do is to, sorry, I'm hearing some interruptions. Sorry.
Yeah. Request all participants to please stay on mute.
All right. Okay. So yeah, someone using the app, they have to come out of their house, take a photo of the sky, and then it would let them know how bad or how good the air quality. Then they can take measurement. They can cover face, or that if they have severe breathing problem, asthma, they can try to stay indoor. So this is a very useful app developed by students from India. Okay, so this really is really inspiring to see what they did, right? And I'm going to click on the next link also. I didn't know about it. I attended this conference in Google in 2019, TensorFlow Dev Summit, and there they highlighted this app. That's how I come to know about it, that this is being done. So if you again click on, there are two links about this. If you click on that, you will know how students develop app to measure Delhi air quality. These are real life problems, and I'm really happy to see deep learning is enabling. And Google TensorFlow, it's a open source, free to all, anybody, anywhere in the world can download it, install it, and develop apps like this. Okay, so I'm going to switch back to my slides. Are you seeing the slides okay?
Yeah.
Okay, so I talked about Air Cognizer. These two links are to do with that. So I'm going to give one more example. All right, so is this page visible, web browser?
Yes, sir.
Okay, all right. So this one is a different story. You take any poor country, say there is an accident, road accident, or some other accident happens. The person is being rushed to the hospital, and not many hospitals have X-ray machines. So they have to go to a specific hospital, and many people die even before they could reach the hospital or before proper care is given. One of the problems they had was if there is an internal injury and if the heart is affected, they were not able to quickly figure out whether the heart is affected or the blood circulation is affected. So they have to take the person to an X-ray machine, measure their heart, how it is pumping, and then using a ruler scale, they have to manually measure the amount of and do manual calculation to figure out whether the heart is working normally or not. If the heart is damaged internally, if the blood circulation is not happening, then they have to give a different care. So the founders of this company called Butterfly, again, they use TensorFlow. They came up with a simple ultrasonic probe, which uses deep learning. And in the field, using a phone, they can measure the person's, whether there is an internal injury or whether the heart is functioning well. So this is another inspiring thing they did. The cost of this was less than $2,000 compared to a massive X-ray machine, which is not even available easily. So these are the kind of impact I see. These are just two examples. Mostly both are related to health, but the applications touch now each and every field using deep learning. All right, so that is this link. You can read about it more. All right, so now why I highlighted few words in this slide. Neural network, right? So I'm going to quickly figure out, because quickly explain what is a neural network, right? So before we go to neural network, let's see, neuron is there are billions of neurons in our brain. Let's look at how the human vision system works. So this is you're looking at another person, and there are certain parts of the neurons that detect, oh, here is an eye, here is an ear, and here is a face, right? Before that, it does multiple smaller detail level processing. Then only you figure out, oh, it's an eye, it's an ear, it's a face. And then you realize, oh, that is Fred. Oh, and you also brain recognize, oh, that's Fred. Fred is my friend, and he's a nice person. All this information happens without you making any effort. And I am not a neurologist or a brain scientist, but I don't think they have really understood how the brain works, really, all of it, but this much they have figured out. So the inspiration for neural networks is very similar. There are multiple layers in the neural network, which you are going to see, and each layer does something. And very similar to detecting the eye or the ear or the face, the initial layers figure out some features, and the final layers figure out the overall features. In this case, if you show a picture of a cat to this machine learning software, it will clearly identify, yeah, it's a cat. It's not a human being, right? So this is just a comparison that's why it's called a neural network. We are trying to mimic human intelligence. At the same time, we are trying to build a neural network model very similar to how our brain functions. All right, this is a more detailed level. And sorry. So in this case, this is a neuron in our brain, and it has connections from all other neurons or some of the neurons, not all of them. And these dendrites are the connections. And then it takes a decision and it is passed to the other neurons, which are next down the line. And there are billions of neurons in the brain. So very similar, a neuron in a deep learning model acts very similarly. So there are connections coming from other neuron, and each of the dendrite assume there is a weight associated with it. And this cell is going to take a decision. I'm getting input from this. Should I really tell the next guy down the line whether he should take some action, or this is nothing, I'm just going to keep quiet, right? That is where this activation function means, okay? Should I really pass this information to the next neuron, okay? So the deep learning models are structured very similarly. All right, now I made another comment here that software to train itself. So I'm trying to explain that actually. So you can read the slides later on in detail, but let me explain this overall, right? So I'm assuming most of you know how to program any programming language. So what do we do traditionally before machine learning, right? This is traditional programming. You have a huge amount of data and you write your program, right? Input is your data, and you write a program, control loop, while, if else, for, you write all of that, and then you produce the output you want. In the machine learning, what we do is let's read this single definition. On the other hand, the input data and output data are fed to an algorithm to create the program. You see the difference? So we first train with both the input and the output. And the machine learning software learns itself. It figures out the algorithm. To do such things manually is impossible, actually. That's what is deep learning is making it possible. Okay, so this will become clear, right, as I explain more. So remember, both the input and the output are fed during training the machine. That is the learning part of it. And then later on, when you use it, you give a new input, it will figure out, oh, I know exactly what this input is, and it will give the correct answer. Okay, again, you can click on this link later on, and you can, that's your homework. So let me move on. So I mentioned training, which is the learning part of it. Okay, there are two phases where we feed in the input and the output to the program, where the program learns itself how to interpret things, right? That is called the training phase. Okay, so that's what is explained here, right? Process of teaching or training a deep neural network using data sets. Okay, so when we talk about input and output together, we call it as a data set, okay, such as image recognition or voice recognition. This is what takes a lot of time and a lot of work. Inference is when you really use it. So in this case, you have already trained this machine learning software, deep learning software, and now you're giving only the image and asking, predict whether this is a cat or a human, and it will know exactly that it's a cat because it has been trained to recognize cat. Okay, so that's what is happening in inference phase, right? Deep learning inference, right? It's the process of feeding neural networks new data which it hasn't seen before, such as images that as DNN has never seen before. Then it will make a prediction what it is. Okay, and the two applications I showed, right? One is the air cognizer, and the other one is the butterfly heart condition detection, right? Ultrasonic device. All those are built using deep learning. Okay, when they are using it in the field, it is really the inference part. All right, so again, I'm going to keep this brief, then I have more details, right? In this slide, I'm mentioning there are two distinct phases, right? Training and inference. And so here, sorry, I'm going back here. In this case, training, what you are doing is, this is where we give both the input and output to the machine, because that is the time, when I say machine, it's basically the software, and it will eventually run on as hardware, right? So you give, so this system is programmed to detect whether it's a dog or a car or a bicycle. It will know only to detect these three things, right? During the training phase, you get thousands of images or even tens of thousands of images of dog, car, and the bicycle. So it is, right? It is trained. Then during inference, you show a picture of a bicycle, you pass the bicycle as a picture, it will correctly detect bicycle. Okay. So what happens is, I will explain it in more. So you send a picture of, during the training, you send a picture of a bicycle, and it makes the initial prediction, hey, it's a car. But you know already it is a bicycle, right? Because we are sending the input and the output during the training phase. Then it knows, oh, there is an error, and the parameters in the network, which are all software parameters, they are all adjusted multiple times. By the time you finish sending all the 10,000 images, the system completely has learned how to detect these three objects correctly. Okay, that's a high level view. So that's what is explained here. Two phases, training and inference. Okay, let's take again, this is from one of the Stanford courses. You can search for this Stanford CS231N in YouTube or Google. You will get plenty of information. Everything is available, right? So yeah, these are for your references. And so let's say we build a very simple system. Each one is a neuron, right? Output is going to tell you during inference whether it's whatever it is supposed to predict. Okay, so let's say the idea is to use 3 days of temperature to predict tomorrow's temperature, right? Something like that. And remember this diagram. This is the input, and each one of the connections has a weight associated with that. Okay, and the weight determines whether the input is important or not, how much importance to give, right? That's what the X is the input and W is the weight with each connection. Okay, so that's when I say the machine is getting trained, what we are doing is basically these weights, initially they are starting with some initialized value, will be completely random. But during the whole training process, the weights, and there is another factor called bias, those are the learned process. Okay, the weights, and because you can't change the input. The picture of a cat is picture of a cat, right? There is nothing to change there. But the weights and biases, W1 and B1, associated with each layer is what is being learned. Okay, so let's give an example. So you have 3 different inputs, okay, and the weights and biases, the W's and B's, are randomly initialized, and the machine is going to, because it's a random initialization at the beginning, the machine is going to make a wrong prediction. It says minus 10.4, okay, and we know, because this is training, we also told, hey, this should be your output. Okay, so now what the process does is, oh, this is my output. Okay, and this is what I'm predicting. And the machine is going to subtract, the error is this minus this, right? And we square it, that's why it's the layer 2 norm, right? So we square it to amplify the effect. And during the backward pass, oh, we started with these randomly initialized weights and biases. Based on this error, the weights and biases are adjusted. Okay, so let me explain that. Okay, so here the prediction is y hat. Okay, that's what is shown here. The y hat is this formula. Okay, basically, if you look at this formula, it is basically the first layer's weight times input plus the bias. That becomes the input for the second layer. That's why it's a W times input plus the second layer's bias, and it goes, right? Now you know the error, which is the real value, actual value minus the predicted value, which is wrong. That square is the error, right? You do a partial derivative of that with respect to the weights of the layer, and there is another factor to control how much to apply. That's how the weights are adjusted. Okay, our goal is to minimize this error. When there is no error, then the machine is predicting exactly what it is supposed to predict. Okay, so that's the idea behind this. And so let me quickly go to another good example. Yeah, okay. So you're seeing this website, right?
Right.
Okay, this is I'll recommend, I have put it in the slides too. 3 Blue 1 Brown is an excellent website. It really explains many mathematical concepts in a visual fashion. So this has an excellent neural network overview. I will ask all of you to check it out. And let's do this, okay? So I'm going to clear this, and I'm going to write a digit with my mouse, and I'm going to ask it to predict. Yeah, so it correctly predicted it as 8. So this is again, there is a network behind it. And when I wrote it, it took the input and passed it through all this neural network. And finally, it has 10 outputs. Whatever is the 0 to 9, it predicts exactly what it is supposed to predict. Okay, so you can go to this link and you can play around. It will mostly predict it correctly. Yeah, sometimes, it's not 100% proof, but the accuracy is very high. So let me go back to the slides. All right. And if you think, oh, this is deep learning, all new technology, right? But it's not. This paper was published in 1989, by Jan LeCun. So he's one of the famous machine learning scientists. And so he proposed this architecture, and that's what is being implemented today, because the hardware and the GPU, they were not that powerful when he really proposed this structure. It took a lot of computing power to achieve it at that time, but now everything is so much advanced, we are able to make use of this. Okay, so I've been showing very simple networks and all that, right? In reality, the networks are very deep. That's why it's called deep learning. It's impossible to go over all the details, but I'm going to just show this is one of the famous networks that was groundbreaking a couple of years ago. After that, there are thousands of networks that has come like this. This is called a ResNet. And there are some operators here. I will try to explain that. Okay, and this is another network called Hourglass. If you look at it sideways, it looks like an hourglass. And I know this network is used for pose estimation. Pose estimation being what pose somebody is currently at, right? There are many applications. One such application I am aware is that there will be a small camera inside your car or truck or any other vehicle you are driving, and it will monitor what is your pose. If you are drowsy, if you are sleepy, or if you're not paying attention, if your eyes are not on the road, but you're looking at your cell phone, it can be detected. That's called the human pose estimation. Okay, so there is a model that was published in 2016, and I'm aware that many of the latest vehicles, cars, and trucks, they use models or similar models to make sure the driver is paying attention, actually. Okay, so that's one of the model, and this is another long and deep model. That's why the term deep learning comes. There are multiple layers, and if you look at here, there are multiple operators here. We call each color is a different operator. Again, it's impossible to talk about all of this and cover in a brief talk, but each one of these operators does something specific. Remember the formula I showed that, let me go back instead of, yeah, this formula, W3, right? W1 is a vector and the X is a vector. And this operation is a matrix multiplication, okay? After learning matrix and matrix multiplication for years, after 35 years, I'm finally putting real use for the matrix multiplication. Again, all of this is done by software, but this is just for your understanding. If you know what is going on behind the scene, that really makes you to learn well. Okay, so I'm going to go to this one quickly. All right, so again, it is written by, there are so many good articles explain. There are many operators I talked about. I'm just going to explain one important operator, and I'll just go right into that. So in this case, I talked about matrix multiplication. And remember, I talked about input and weight. The product of input and weight is a matrix multiplication, okay? In this case, it's a 4x4 matrix, and the weight is never the same. It is always a little smaller. It is a 3x3 weights. So what is going to happen? These weights are applied to various parts of this matrix. This is for explaining it. In the case of a air pollution image or or the heart image, right? Imagine this as a digital photo. A digital photo, when it is saved, it is nothing but a set of numbers. I hope you all understand and agree, right? When it is stored in the web or anywhere, even in your local drive or your phone, it is stored as a set of binary digits or set of numbers to keep it simple, right? And here it is 4x4. In a typical big size photo, it will be maybe 5,000 pixels by 7,000 pixels, right? And each pixel has RGB value, red, green, blue value, and another factor, right? So those are 3 different channels. So you can imagine your photo as a three-dimensional matrix of numbers. That's how the machine learning software sees it. So the weights, when I say the W times X is a matrix multiplication, that's what this one is showing, right? See the weights moving around for the red channel, green channel, and the blue channel, right? So when the matrix multiplication happens, this huge pixel array is turned into a much smaller important numbers. So when that's what it is. So if you look at it, 45, this highlighted matrix, 3x3 matrix, multiplied by this 3x3 weight gives this number. Okay. So what happens is, yeah, that's pure matrix multiplication. That line is explained here. That's same as the formula I showed you, actually. Okay. So, yeah. So when really, whether it's a human being or recognizing a car or a bicycle, what is happening, the machine learning software really knows only numbers. It has no clue that it is a bicycle or a car or a human being. All it does, that's what computers do very well. Zeros and ones, right? These are all numbers. So anyway, so that's why there are multiple operators. The important one is the convolution operator. That's what I explained here. Again, go to this link and you can read more about it. All right. So I would like to stop at this time. You saw what deep learning is. It's a neural network. And it needs a vast amount of data during training phase. The quality of the data will determine how accurate it will make the prediction, whether it's a heart or air quality or any other app, right? So I will stop the technical part up to this point, and then let me talk about briefly what are the jobs that are that one could be working on. Any one of you could be working on, right? So of course, you will do a bachelor's, and it doesn't matter, electrical engineering, electronics, or computer science. But if you are able to go all the way up to PhD in machine learning, then you will be in the process of designing models like this, right? And if you look at it, this is post-estimation. This is recognizing images, right? And this is also recognizing images. That's what the air cognizer and heartbeat, heart function, ultrasonic device did it, right? Recognizing images, right? So you would be designing models to solve a specific problem, okay? Now, that is pure on research. You should know more about the domain as well as more about the machine learning aspects. Then you can design models to solve specific problem. And an important part is taking these models and turning into a product like the air cognizer app or the butterfly heart device, right? That's where software engineering comes, right? You need a bachelor's or master's in computer science, right? You take this research and make it into a product. We do a lot of that in Qualcomm. So I'm not a PhD, but my work falls into number 2 here. But it's very important, right? It has to be bug-free, it has to be reliable. But I get a chance to interact with the research people, understand their idea, and bring them into products. Okay. Now, all the other, and the self-testing, you don't have to be doing this, you don't have to be doing this, but you still need to understand deep learning. One can completely go into testing. These models need to be trained and they need to be tested before they could be released to any use, right? And I'm just highlighting this number 3 would fall into any of this, but I want to highlight this is an important area. I'm sure some of you would have used Siri or Alexa or Google, hello Google, right? All of this as natural language processing, NLP. As long as there are human beings in the world, and as long as they are talking to each other, and as long as there are 200 plus or more languages, any Google translator, everything internally in your phone, you are all using machine learning in one form or another. Okay, so when you take a picture with your cell phone, and before it is saved, machine learning is used to make the picture brighter, much crisper than what you took. Okay, so that is one application. And natural language processing, any language can be translated to any other language now. All that what you're seeing is deep learning and natural language processing. Same thing happens in Siri and Alexa and Google Voice applications. Okay, so there are many variations, but they would fall into each one of these categories. Okay, it could be a finance app. It could be predicting the stock market based on past history. All of that will fit into these categories. All right. Now, what are the, could you tell me how much more time I have?
Sir, you can go on till about 10:50, another 5 to 6 minutes.
Okay, all right, that's good. Coming to an end. Okay, good. So, all right. So I'm not sure whether you may be already familiar with some of these sites. These are excellent online learning platforms. So what I did in Qualcomm is, like, while I was working my other job in wireless related work, I did a nano degree in Udacity, which is 3 quarters and 10 months. I will come home evening, do the courses, weekends, I will spend time. That's how I learned machine learning. So each one of you can do that too, okay? Whether you're a student or you're already working, right? So these are good online platforms to learn machine learning. And some of them have the introductory courses, some of the machine learning, deep learning courses, or some of them have free. I haven't checked recently, but Udacity is the one I would recommend. And yeah, many courses have fees associated with them, but Udemy is really low cost, but they also do a very good job of teaching machine learning. And there are so many, I pulled out the Stanford slides, which I used. They're all online, available, free. And same with, you can check YouTube, so many introduction to deep learning and machine learning courses are available free on YouTube and internet, right? Some of them are hosted in the college website itself, okay? So again, we looked at it already, the 3 blue and brown, where I wrote a digit and it recognized. Check out this site. They have a very good 3 or 4 videos on neural networks. Okay, and some of the, again, PyTorch is a machine learning framework. Everything I explained can be very easily done by writing a simple program. I showed the air cognizer and the butterfly device. They were all done using TensorFlow, which is Google's machine learning framework. And PyTorch is Facebook's machine learning framework. These two are the top used frameworks. And if you learn one, you can start with any. PyTorch is somewhat easier to start with, but TensorFlow is also very good. Most widely used is TensorFlow. So, but you can try out this. If you go to these places, there are tons and tons of videos, right? And you can learn. Okay, this is, I'm not going to go over it. This is using PyTorch. This is all you need to do. I talked about the convolution operation, right? So this is a very simple way. You don't have to worry about matrix multiplication, okay? So it's all done internally by these operators, but it's always good to have the fundamentals correct. So that's where learning statistics, linear algebra, and matrix is very, very important for deep learning. Okay, and what skills are required? Of course, just look at the first one I'm using, data structures, okay? Very, very important. So computer science, data structures, algorithm, Python. Mostly I have used only Python in the last 4 years, and C++ sometimes. And this is all I mentioned. And knowing the framework, which is Google's TensorFlow and Facebook PyTorch, and good software engineering and design skills, right? So these are the key things. Yes, as a student, you will be learning these things in your first job, some of it, but having good basic fundamentals in data structures, algorithms, and programming languages is very important. And since Michi is associated with Japan, and I also probed a little bit into what is happening, the state of deep learning in Japan. I came across this. I'm really not an expert, and I did my own finding and came across this. This looks very interesting. And so you can check this out later on. And when I look at the members, right, they have some regular members and all the big name NVIDIA's here. And then they have expert members. Then when I look at it, all the companies are important companies, Hitachi, Western Digital, and Alibaba Cloud. And then silver members, Docomo is another phone service company. KDDI is also just like any other cellular provider. And Microsoft, Cerebras, all these are fantastic companies. So you can, and also they seem to be doing a lot of certification and training. Those kind of activities are also done by the Japan Deep Learning Association. Okay, so you can check out, and I was looking at it, and yeah, here is a deep learning overview. Okay, so yeah, this, I'm assuming these things will go into more detail, but definitely check it out, please. Yeah, okay, and then finally, yeah, I'm concluding. So it's one of the many important deep learning. There are many domains. I haven't even talked about so many different other models and techniques. I focused only on deep learning, given the amount of time, but it is one of the most important domains within machine learning and artificial intelligence. And the applications of DL are expanding rapidly. I'm seeing more and more. And the accuracy of the models, right? A model is good only if it predicts correctly. The latest thing I read about, it says for detecting cancer from X-ray images, the machine learning models are doing much better than humans, human doctor or a radiologist who is going to look at these pictures, because definitely humans are bound to do mistakes, but computers, they deal with zeros and ones, right? Okay, there may be a software bug, but eventually the accuracy is getting better and better in some of the areas, actually. Okay, I would stop here, and let me know if you have any questions.
Great introduction to deep learning, sir. It was really, really insightful. So, I mean, in the limited amount of time, you have provided a very insightful approach to how can one approach deep learning as an outsider also.
Yes,
so
correct.
That was a very what do you say, simplified approach that I could see. Thank you, sir. So
yeah, thanks. Yeah,
those of you who have a question can please ask in the chat section. Up to 10 questions as part of this session will be asked to the speaker. So those of you who have a question can please go ahead and ask. You can even unmute yourself and ask a question in case you have.
Yeah, this is Kavita here.
sure, go ahead. Yeah.
Yeah, hi. Sir, I just have a doubt. The latest laptop and the mobiles, we use finger or the face prints to be recognized to unlock the. So does
Correct.
it fall under the two-phase model of the machine learning, where does it fall under the train yourself pattern, where the data sets are where the image and the voice recognition matches, then you log in? So does it fall under this? Can I map that in with the data set train yourself phase?
Yeah. Oh, yeah. Okay. All right. Very good question. And I have personally worked with fingerprint sensors as part of Qualcomm because it is part of the cell phones. And your question is, sometimes you take your own, you put your own fingerprint to train it. So what, or your own face, right? For Face ID. Definitely, I guarantee deep learning is behind the scenes here. So what is happening is, when we train with a fingerprint or a Face ID, the machine, let's take the fingerprint as an example. So if you look at your thumb, right, there are what is the correct word? Biological definitions for the lines and the ridges and the curves in your thumb. Okay, so what the machine learning system for fingerprint sensor, it is trained to identify the ridges and the curves and the lines, the smaller parts, right? Then when you take two or three times, you may have to use your own fingerprint. So when you do that, there is a very little bit of training happens, but it is not like a majority of the training has already been done to train the system. But in addition, you are providing some additional data, which will have more weight. So that's where the customization of your face or your fingerprint comes into picture. Good question. I have personally worked with fingerprint sensor models for deep learning.
Oh, that's good, sir. Yeah.
Okay, one Mr. Ramesh, his question is, what are, to share a few applications Qualcomm uses in their mobile phone chipset or something using machine learning, deep learning?
Okay. So I'm really happy to talk about it. That's what I do day to day. So for example, fingerprint, that the previous question, that's one of the things the group I did in played a major role in optimizing that model. And I already mentioned, when you take a picture, what you see in your phone is not the picture you took. The picture you took is very bad, believe me. Okay, and it's a machine learning. Okay, I'm joking, but I'm sure there are excellent photographers in this group. The machine learning software, it knows if certain area of the picture is out of focus, and it fixes it actually. Okay, and if you take a picture with your iPhone, whatever you do, the picture is going to come out very good. Okay, and same with Samsung phones or any other phones, right? And that is also machine learning is behind the scene. And Qualcomm is big in 3G, 4G, 5G, and all that, right? For radio frequency signal, how to connect to the network, how to pass the data, and what is the connection quality. If the connection quality is bad, what needs to be done? Should I be connecting to this tower, or I already see another cell tower? Should the handover should happen to the next tower, which is better? All those things, each and every, there are within the phone, there are like 30 or 40 different software groups within Qualcomm, and each one of them are using machine learning. Okay, another thing is the voice. I never talked about it. One is the, for example, I talked about Alexa and Siri and Google, right? These are just few of the applications. Pretty much you take any Xiaomi, Oppo, Vivo, these phones, right? They all use the Qualcomm chip and the software. And there is a lot, it's not just the phones. We are into autonomous vehicles, and there are multiple cameras embedded in a car to sense the road and to steer the car right in the middle, and multiple applications. I'm not talking about autonomous driving. Even before that, there are many safety features are already using. So we are using that. And you must have heard of the Ring bell, right? Which has a calling bell, which has a camera as well as a Wi-Fi connectivity. And that is also deep learning. And that's, we have played a role. I am very proud of the Mars helicopter that was sent to Mars and which is still flying after all these months, has a Qualcomm Snapdragon chip, and that uses a lot of machine learning to navigate. You should watch YouTube videos on the Mars helicopter using Snapdragon Qualcomm chip. Yeah, so I will stop here. I can keep talking. There are many like that. So.
Thank you, sir. It was so. Anybody? Any other questions? So one Mr. Vimalesh is asking, what will be the entry-level requirements that any company will look to hire a person in the ML or the AI domain? So do they say consider certificates from Coursera, Udacity, or do they see personal projects? So what will be the path?
Yeah, again, good question. Yeah, so right now the demand is very high for people in this field. So I would recommend doing anything you can do in terms of certifications. For example, I talked about my Udacity experience, right? There was no machine learning group. I just learned it on my own. For 10 months, I learned. I did some projects. Right around the time, Qualcomm was starting a group right in this area. I did it for my own interest and passion. And basically, I put all my projects in one of the Qualcomm network drives. I met with the team's lead who was building up the team, and we talked about all the projects I did. So the degree or course or those kind of things are important, but those are not, at least in US, that's how it's very casual. If you're able to work on it and show your work, then that has more weight. I'm sure it is everywhere that is the norm. I would say develop the skills, develop the understanding. Okay, in my view, in US at least, bachelors, they don't cover machine learning courses in detail, because bachelors, they have to know about everything computer science, the basics of computer science. When you go to master's level, you can do a master's specifically focused on machine learning topics. So if we're not planning to go to master's, that's okay. That's where these online courses are coming into play. They would be absolutely valued, right? And Udacity courses are just like any other universities. Just like when I took the Udacity course, they basically brought engineers from Google, Mercedes, and NVIDIA, and they were the one training us when I did the deep learning course in Udacity. So that only helped me to break into. I traditionally before that, for the 25 years, I worked mostly on communication and wireless. I had zero knowledge about machine learning. So yes, all those courses help.
Okay. So I think we have reached the end of the session for today. It was a very interactive and informative session. I mean, truly appreciate the effort to simplify such a complex topic in such limited time and render it so effectively. And patiently, you have responded to most of questions asked by our participants. Thank you so much, sir. It was really a pleasure and honor having us on our Michi. Thank you for taking off from your busy schedule and giving us your valuable knowledge. Thanks a lot. And thank you all the participants also for actively participating.
Yeah, thanks a lot. Thanks for the invitation. Anantu is a very good friend of mine, and he contacted me and asked me to do it. I'm very happy to do this. And yes, please use the links. Do your homework. You will be fine. Okay. All right. My best wishes to all of you. All the best.
Thank
Bye-bye
you,
now.
sir.
Yeah.
Thank you. Thank you all.
Thank you, sir.
Okay. Bye-bye now.